Gas pressure is directly proportional to the number of moles of the gas particles N and inversely proportional to the volume of the gas. It's also directly proportional to the temperature as long as the temperature is measured in Kelvin. Gas pressure does not ideally depend on the type of gas. No matter what type of gas, if you have a certain number of particles, a certain volume, it will be at a certain temperature. In other words, no matter what gas, the ratio of PV to NT will be constant, or PV divided by NT will give a constant, and that constant is 8,3 as long as you've used SI units, and that's true for any gas under any conditions according to ideal gas laws. No matter what kind of gas you have, if it has a certain number of particles, a certain volume, and a certain temperature, it will have a certain pressure. In other words, the relationship between PV, N, and T is independent of the type of gas, whether it's hydrogen gas, helium gas, oxygen gas, nitrogen gas, or whatever gas. Put another way, you get a constant when you multiply P by V and divide that by the product of N and T. PV over NT gives you a constant no matter what gas you have. And that constant, if we are using SI units, is 8,3. And that's a special value, and therefore it's given a special symbol, R. R stands for universal gas constant. So a consequence of gas pressure being directly proportional to number of moles of gas particles is that pressure divided by number of particles gives a constant for a certain volume and temperature. A consequence of pressure being inversely proportional to volume means that pressure times volume gives you a constant for a particular temperature and number of particles. A consequence of pressure being directly proportional to temperature for a gas, as long as temperature is measured in Kelvin, is that pressure divided by temperature gives you a constant for a particular volume and number of particles of gas. A consequence of all these combined is that PV over NT gives you a constant, and as long as we've used SI units, that constant is 8,3.